Alright guys, so I got a request to make a video on how to use the quadratic regression function in the Ti-84 calculator. Alright, so yes, there's my Iron Man background. Alright, so you get your Ti-84, Ti-83, whatever calculator, and you go to, first you got to make a list. So you go to stat, and then this will take you to all of your different functions for your lists, which are your L1, L2, those guys. You can see those. And so like in your plot 1, plot 2, plot 3, you can plot your lists using these functions. And we'll get to that in a little bit. Alright, so first let's go to our stat and edit our stat. So first, before we use the quadratic regression, we have to make our lists. Alright, so let's go ahead and just make a simple list. We'll use 5 points. So these are like our x values. And we'll go over here. In this column L2 will be like our y values. So we can go ahead and make this 1, 4, 9. We'll call this one 15, make it a little bit off. And we'll call this one 26. Alright, so now we've completed our x column and our y column. So now we want to go back to stat, and the first one's all about editing our lists. Calculate is all about doing things with our lists. So there's different things here. Linear regression is similar to quadratic regression, but we're going to use in this video the quadratic regression. So we'll go ahead and select 5 and press enter. So now it wants to know what is our x list and what is our y list. And then this here, frequency list. Not sure what these guys do. Let's see what happens. Press enter, calculate, and it gives us all of our information. Now, some calculators have it a little bit different. This calculator has the full update. So let me see if I can use it the old way. If you go to calculate, yeah, it's going to take you straight to quadratic regression. Alright, well, I'll show you how you will do it. If you don't have the update, what you're going to do is, so when you press the quadratic regression button, when you press that, you're going to show up to your main home screen. You're going to show up to this screen here, and it'll say something like, let's see if I can, Q, U, A, D, R, E, G, something like this. It'll say quadratic regression. And so now what you would do is, and then it'll have like a little space there. Let's go ahead and turn off alpha lock. So it'll say quadratic regression, and then it'll give you the blinking cursor here. And what you would do is, you would go to second stat, which gets you to the list menu. Go there. You'll click L1, and then you're going to do a comma, because whatever you select first will be your X list, and whatever you select second, that'll be your Y list. So we'll go back to stat, to the list, sorry, and then you click on L2, press enter, and then what you would do is you would press enter. Now if I were to press enter right now, it wouldn't do anything because I have the update, and this quad reg, what it says right here, doesn't mean anything. But what it would give you is this information right here. So it would give you this information right here. This screen would pop up, and what this tells you is you have it's telling you that it'll fit this function here, the y equals ax squared plus bx plus c. A will equal this number, b will equal this number, c will equal this number. And what you can do is plug these into, if you wanted to fit this to the plot that we've made, the x and y points that we've made. And actually, if you don't have the update, it'll actually also show you the r squared value, and I'm not sure how to get that with the update. The r squared value just tells you how closely it fits, how closely those points fit the quadratic regression that it's created for you. So if we wanted to, this is 1.21, 1.28, and then 1.2 again. So let's go ahead and type these in here. 1.21 x squared. We can go back home. Oh, it's not there. Let's do second entry. Alright, so we have to go back to stat. Actually, kind of jealous of you if you don't have the update. It's kind of a pain. Alright, negative 1.185. We'll call that 6, so negative 1.186. So minus 1.186x. And then the last value was positive 1.2. So let's go ahead and graph that. Alright, and then we also had, let's go ahead and turn on plot 1. So if you want to turn on plot 1 and see the points that we put in, you want to turn on plot 1 and then graph again. So then it'll give you those points, and then you'll notice how, let's change the window here. Let's go 0, max 10 is fine. Let's set this to 30, graph again. You'll see how these pretty closely will hit these points. Now because I set these last 2 points off a little bit, it doesn't go exactly through. But this is the quadratic function, the second degree polynomial, which most accurately passes through these points here. So you can use this in problems that ask you to kind of plan what will happen in the future. So if we were to change our window here, say this was 50, graph it again. Say I wanted to know something that'll happen. This is 5, so at 6. Say at 6 or 7, what'll happen then? And you can say that it's with some amount of certainty that it'll land directly on this line. And you'll be pretty close. You can see how close these points are, so it'll be pretty close to this actual line. Or it might be something in between. You can use this to kind of plan for the future, and that's what the quadratic regression is typically used for, along with the linear regression. The linear regression is also to plan for things in the future. The quadratic regression, you can see how closely this fits. If you wanted to see the linear regression, let's go ahead and try that really quick, because that's very similar. So linear regression, and again, if you don't have the update, it would give you the exact same window. It would have linreg would show up on your home screen, and you would type in, you would select L1 and L2. You can go back a little bit in the video to find those, how I did that, and it'll give you that option, and then you'd hit enter, and then this information would show up, along with the r squared value, which tells you how accurately this line is. So if we wanted to, we could select these values. We have 6.1 and negative 7.3. So let's go here. 6.1 x, and it said negative 7.3. I think it was, so we can go ahead and graph this also. So you can see how this line pretty closely matches up with these points. And again, this is the most accurate line that would cross through these points. To know for sure that this is the most accurate line, that takes a little bit of calculus, along with the parabolic function. That takes a little bit of calculus. But you just need to know that this line and this quadratic function here are the most accurate functions that pass through these given points, or any given points that you put in. Alright, so hope this helps, and good luck on your homework.